Hi geometry students, we are continuing the second day of lesson 24-2 and we are on page 342. We are going to be pulling out pages 342 through 344. So we last left off on completing numbers 4 and 5, so we are going to be looking at number 6. So let's go ahead and pull that problem on up. So let's start looking at number 6. It says a chord of a circular clock is 12 inches long and its midpoint is 8 inches from the center of the circle. So we're going to go ahead and draw a picture to represent this. So I have my circle drawn. I'm going to go ahead and draw the center point as well. So now we're going to go ahead and draw a chord on the circle so we can just visualize this in any way. I'm just going to go ahead and draw it looking like this. Perfect. So that's my chord. And remember from last time that we know that if we had our radius go through the chord, essentially it's our diameter, but if we just want half of it, right, then we know it's our radius. We know it creates a 90-degree angle. We also know that it creates the chord bisected. So we know each of the segments will be congruent to each other. So essentially, since we know that this whole length is 12, what does this length be then? It will be 6 units. Perfect. So it says we know its midpoint, right, is 8 inches from the center of the circle. So again, circle might not be drawn to scale, but this is our 6 units long. This is actually going to be 8 units long. That's kind of what it's telling us here. And then it wants us to figure out maybe what theorems we can use to determine the length of the radius of our circle. Well, before we get to that, we want to figure out how we could draw the radius of our circle. So our radius, remember, is from our center point to any other part here. Remember, we're trying to use these pieces of information, this distance and this distance. So it's kind of helpful to draw the center, right, and our radius to be connected essentially from our center to the end point of where part of that chord is. So look at this. If we're creating a 90-degree angle here, think of what shape this makes and think of what theorem we could use to find this radius x. Which theorem do you think it is? That's right. It's actually going to be the Pythagorean theorem, Pythag, right? It's popping up a lot more than we expected. So looking at this, we now want to calculate the radius of our circle. So let's go ahead off to the side. Let's do our Pythagorean theorem, right? We have a squared plus b squared equals c squared. So we're going to have 6 squared plus 8 squared equals c squared. So we're going to have 36 plus 64 equals c squared. That gives us 100 equals c squared. So when we take the square root, boom, we get 10 inches. So that's what we're going to put as the radius of our circle. It's going to be 10 inches. All right, cool. Now that we're putting some of these ideas that we've learned into practice, let's go ahead and look at number 7. So I'm going to go ahead and scoot down below and use number 7 kind of over here. Let's try this. Yeah, perfect. Right down here. So it says a chord of a circle is 15 inches long and its midpoint is 9 inches from the center of the circle. It wants us to calculate the length of the diameter of the circle. So I want you to go ahead and see if you can kind of practice drawing a picture. So let's see if you can practice drawing a picture. Pause the video and we'll come back and then talk about it. All right, so here's what I drew as my picture. So similar to the problem above, just a little bit on a slant. I drew my chord, which is 15 inches long. I know that if my diameter is going through my chord, that it creates a 90-degree angle. So it kind of creates and sets up this right triangle if we extend our radius here. And then I have a certain length here, right? It's 9 inches from the center of the circle. That's what our chord is. Again, our chord is bisected, so this length is 7.5. So it wants us to find our diameter. Well, that means we could find the radius here and then just double it. So that's kind of how I set up my picture. Now we can easily solve for the length of r, again using Pythagorean theorem, and then doubling that number to get our result. So I'm going to have you go ahead, pause the video right now, go ahead and apply Pythagorean theorem and see if you can solve for our diameter. All right, so what I did was I applied Pythagorean theorem, and as you can see, I got our radius to be around 11.7 inches. So when I doubled that, I got our diameter to be 23.4 inches. So that's the length of our diameter of this circle. Now, it's okay if you rounded to 2 decimal places. That's totally fine. I just rounded to 1 to keep it simpler, but you should get the same result regardless. Now let's go ahead and look at number 8, where we're going to be introduced to a new special type of relationship with chords. So it says intersecting chords in a circle also have a special relationship. So again, it says use a protractor and a ruler. We're going to do our best to just kind of sketch and draw a picture of a circle off to the side, and that's totally okay if we're eyeballing it. So I'm going to go ahead and draw my circle. Ooh, let's try that one more time. Let's see if I can get a little bit more circular. There we go. So I have my circle. It says draw a circle with chord AB. Okay, so I'm going to draw chord AB. So let's pick a color and let's just draw perfect. So that way I have AB, and then it also says to draw a chord DC or CD. I mean, it doesn't really matter how you draw it, but it wants to make sure that they're intersecting in some way. And I'm purposely choosing to make their intersection point not necessarily the center of our circle. So it doesn't matter which one we want to label, AB and CD. So I'm going to choose to label on my red line AB. And then my blue line, I'm going to label CD. Beautiful. All right. And then what it wants us to do is to label the intersecting point. It wants us to label it point X. So I'm going to call this right here point X. So it wants us to measure the following lengths. Okay. So I'm actually going to give you these lengths just to make it a little bit simpler. So I'm going to give you the lengths. So I'm going to tell you that AX is going to be a measurement of 3, XB is going to be a measurement of 4, XC is going to be a measurement of, let's try that again. It's going to be a measurement of 6, and then XD is going to be a measurement of 2. So let's go ahead and write those pieces down. Awesome, looking good. Okay, so now it wants us to find the product of AX times XB, and then the product of CX times XD. And we're going to see if we notice something. So let's go ahead and we're going to take AX, which is 3, and multiply it times XB. So we're going to go ahead and do that. So we get, when we multiply 3 times 4, we're going to get 12. So I'll write it this way. Perfect, that's looking good. And then it wants us to try multiplying CX times XD. So we're going to multiply 6 times our 2. So we're going to have 6 times 2. Again, that's going to give us 12. Well, what do we notice? We notice that these are equal. We notice that they're equal, right? So interesting. So it says compare your answers with your neighbor's results. Obviously, we're kind of doing this on a video, so we're going to compare all together, and we're going to see what conjecture we can make based on our investigations about intersecting chords of a circle. So what we're going to do is we're going to see when we have 2 chords that intersect, we're going to see the product of the lengths of one chord. So, AX times XB is going to equal the product of the lengths of the other chord, which was CX times XD. So we're going to go ahead and write that down right now. So we're going to say when 2 chords intersect, the product, let's try again, the product of the lengths of one chord equal the product of the lengths of the other chord. Cool. So we were able to find out that AX times XB was equal to CX times XD. That was our investigation that we saw. So now, here's what we're going to do. We're going to go ahead and pull out our word wall that we saw from last week, and we're going to go ahead and add onto it. All right, so this is where we last left off from last week. So we're going to go ahead and go to the bottom, right where it says the chord product theorem, which is technically the official name of what we just discovered. So I'm going to go ahead and kind of recreate and draw the same picture as before. So I have points C and D. I had them with the blue line, and then actually, you know what I'm going to do? Instead of labeling each of the points, what I'm going to do is I'm going to label kind of those distances that we have, those lengths. So I'm going to have 2 intersecting, Maybe we can make that a little bit better. I'm going to have two intersecting chords. And I'm going to label this is lowercase a, lowercase b, and I'm going to label this lowercase c, lowercase d, talking about the length. So we realize that when we multiply a times b, it's going to be equal to the distance of c times d. So we're going to see that we have each of these pieces, when multiplied together, is going to equal each of these pieces multiplied together. So now that we've had a chance to add this to our word wall, let's go ahead and practice this idea. So let's go back to the textbook. We are going to skip number 9 and jump to number 10. So skipping number 9, we're going to go ahead and jump to number 10. So let's zoom in a little bit. All right, so it says in our circle shown, what is the measurement of x? Show your work. Okay, I want you to see if you can use kind of this chord product theorem that we came up with to set up an equation, and see if you can solve for x. All right, so using what we know, we're going to go ahead and take x times x and multiply them and set them equal to 49 times 4. So we're going to have, let's pull out a pen, not a highlighter. So we're going to have x times x and set it equal to 49 times 4. So that way I'm going to have x squared. And then I'm going to go ahead and multiply those ideas together. So I get 196. And when I take the square root of both sides, I'm going to get x equal to 14. So voila, we were able to solve for what these two side lengths are going to be. Let's go ahead and turn to the next page so we can practice some more problems together. All right, we're going to go ahead and zoom on in. We're going to go ahead and look at question 13 for starters. So I want you to go ahead and read through question number 13 and see if you can come up with an answer as if Sarah is correct, Seth is correct, both are correct, or neither are correct. So looking at problem 13, we can see that Seth's statement is correct, right? So Seth's statement is correct. And our reason behind this is because all diameters of a circle are chords, since the endpoints of a diameter both lie on the circle. So we're going to say all diameters of a circle are chords. Since the endpoints of a diameter both lie on the circle. And we obviously know not every chord is a diameter because not every chord goes through the exact center. Alrighty. Now, next problem we're going to go on to is number 17. So let's go ahead and look at number 17. It says in the diagram shown, explain a method for determining the values of x and y. Then find x and y to the nearest tenth. So I want you to go ahead, pause the video right here, see if you can look this over and come up with a method for figuring out how to find x and y. So here's what I'm thinking. Based off of what we just learned, technically these are two chords, right? Couldn't we set up the chord product theorem, right? Couldn't we say 20 times y is equal to 16 times 16? Sure we could. So we have 20y equals, well, what's 16 squared? Well, 16 squared is going to give us 256. And then when I take 256 and divide both sides by 20, right, I'm going to get y equals around 12.8. It does say to nearest tenth, so it's looking good so far. So I found out what y is. Okay, so now that I know what y is, anyone have an idea of how to find x? Yep, exactly. We're going to use Pythagorean theorem. So we first started off with chord product theorem. And then we are going to go to Pythagorean theorem, right? That's where we have our a squared plus b squared equals c squared. And technically we do have the length for y, right? That's going to be 12.8. So I could say 12.8 squared. I could add that to our 16 squared. And we want to solve for c squared, which is technically x. All right, so let's say we went and did this. We should get a value for x, or aka, right, aka c, right? We're solving for x, solving for c. So we should get around 20.5 units. So look at that. We were able to solve for both x and y using kind of what we know of the chord-chord product theorem and the Pythagorean theorem. Now, you're going to have some homework for tonight's class. So on the calendar for Miss Graham's class, we have lesson 24 practice. So far we've covered lessons 24-1, and today we just finished up lesson 24-2. So what I am going to have you do is you are going to pull up that practice worksheet, and you are going to complete the selected problems on there. This worksheet is technically 4 pages, but we are not going to go through every single problem that's on those 4 pages, just the selected ones. And for today, you can actually only do the first 3 pages of the problem specified, because tomorrow we're going to look at lesson 24-3 and finish that up. So I would go ahead and get a head start on those selected problems. They should be circled on the worksheet for you to work on. We will come back tomorrow and see if you have any questions. So happy mathing.